In square ABCD, P is the midpoint of DC and Q is the midpoint of AD. If the area of the quadrilateral QBCP is 15, what's the area of the square ABCD? So I just wanted to point out a very common mistake is trying to find out no, it's not finding out the area, but it's like you're trying to find the area of the square first, but you don't even know the units of what the square is. I mean, there's no point of doing that. They spend the whole test just trying to get that one area, so it's not going to come in very helpful. The correct thing to do is actually let's call this x. Let's call each side x. This would be x, and this would be x over 2. And these two lines here, they mean congruent, which means they are exactly the same with this and this. So this is 15, but we don't even need to know the number we only need the number of either this, or this. Actually, it doesn't matter which one we have, because we already know this. So we already know the formula for solving the triangle. It's base times height over 2. This means it would be x squared, which is the formula for the whole square, subtracted by this is x over 2 multiplied by x over 2. X over 2 squared, then over 2, x over 2 squared, x squared over 2 squared over 2. That's x squared over 8. We subtract the x squared minus 4 for this one. X squared over 4. So we have to multiply this by 8, multiply by the denominator by 8. Get 8x squared minus 8x squared over 8 minus x squared over 8 subtracted by, multiply this by 2, multiply this by 2, 2x squared over 8. So then when you subtract them together, it's 5x squared over 8. So that is what we figured out to find the area of what this is, which is equal to 15. Hold on, I have space here. Okay, 15. So we just, let's see, I need more space at the bottom. I still want to see the question. Okay, that means 5x squared is equal to 15 times 8. 15 times 8, which is 150 subtracted by 30 equals 120. And then if you want to isolate the x, then x squared is equal to 120 over 5, which is 24. Therefore, the answer to this is E. This is a question 24, I believe. This is a question 24 on the Math Gauss Grade 7 2009.